Okay, example 1, right? The directions for all these examples are solve the system, right? The system, of course, of linear equations. So our system is, right, this is our system, is 2x minus 3y equals negative 4, and 2x plus y equals 4. So to solve the system of linear equations basically means that you're going to graph both lines. And so the first one, right, I'm just going to call L1 for line 1. And the second one, I'm going to call L2 for line 2. And remember that in, let me just get my pointer here. Remember that in 7.2, right, you learned how to graph lines. So you can graph this line and this line by using the intercept method or the slope-intercept method. None of these guys are already in slope-intercept form, but you can put them in slope-intercept form. It's not too hard. So I'm going to, let's see, I'll do the first one well, I guess I'll find the intercepts, right? It's not too bad. So find, again, just to get a variety of, uh, of methods. So find the x-intercept. So we're going to let y be 0. So 2x minus 3 times 0, that's gone. 2x equals negative 4. So x must be negative 2. So what is my x-intercept that I found? My x-intercept is negative 2 comma 0. Okay, so let's do the same thing. Now let's find the y-intercept, right? So we're going to let x be 0. And again, the same line, 2x, but x is 0, so this should be 0. 2 times 0 minus 3y equals negative 4. And that's gone, so negative 3y equals negative 4. Well, negative 3 times what is 4? It's probably going to be a fraction. So let's divide by the coefficient, because this is a big 1. And we get y equals 4/3, right? And a third of $4 we know is 1 1/3, right? 3 times 1 is 3, plus 1 is 4, right? That nice check. Okay, so we found 0, comma 1 1/3. Okay, so if I quickly graph this, well, let's plot the points in order to graph. So I'll move that up there. And let's see, we have our y-axis and our x-axis. And so negative 2 comma 0 is right there. Excuse me. 0, okay, here's 1, here's 2, so 1 1/3, 1 2/3, so 1 1/3 is right there. And if I connect the dots, right, this is my line 1. Okay, so now let's graph line 2. And line 2, let's see, is 2x plus y equals 4. So 2x plus y equals 4. Again, you can use the intercept method. I'm going to use a slope-intercept form because this is a quick, I mean, there's your 1y. So if I subtract 2x from both sides, right, that's gone. I get y equals, I'm going to write my x value, well, my x term first, plus 4. Right, if you write 4 minus 2x, right, that's the same thing as negative 2x plus 4. I just like writing this first because that's basically my slope. So y equals mx plus b. So our m is -2 or -2/1. Rise over run, so rise, so I'm going down 2, and then I'm going to the right 1. Again, if you want to write 2 over -1, then you would go up 2 and to the left 1, right? It doesn't matter. You're still going to lie on the line. Y-intercept is 0, 4. Okay, so let's graph this. So 0, 4 and -2. So 0, 4 is 1, 2. Okay, let me maybe make more room here. Let me get the eraser. Oh, okay. Well, while I try to fix this eraser, you can graph it. What's going on here? Let's see. Pencil, eraser, and okay. It's not sure why it's not letting me move. Okay, ignore that line right there. Okay, let me just move this up. But we know, okay, this is 1, this is 2, and I'm trying to plot, what was it, 0, 4, and then -2. Okay, so 0, 4, so 2, 3, 3, right, and let's just say that's 4. Oh, I'm sorry, I feel really bad. I'm not sure what's going on with the eraser. Okay. So 0, 4 is right there, according to my graph. And remember, the slope is -2 over 1. So that means I'm going to go down 2. So 1, 2, right? There's my, so again, 1, 2. And then to the right, 1. So let's say 1 is right there. Right, there's 2. So down 2 to the right 1. So 1 is probably right there. And if I graph, right, if I connect those points, right, I get this. So what is my intersection? Well, let's see. That looks like 1, 2. Right, 1, 2. And again, you need to use graph paper. To be honest, I mean, here I kind of got lucky with this solution because there is error. I mean, if you don't have graph paper, then you're basically saying, I kind of wish I was a little bit off, because then I'm saying that, okay, this distance is 1, right? Which is the same thing as this distance, which is the same thing as this distance, which it kind of looks the same, but then we're saying, oh, it's the same thing as this distance or this distance. If you're off even by a little bit, I mean, your point, if I, for example, if my red line, let's say I just decided to, draw it like this. Well, then it would intersect right there, and that's not really 2, 1. So, I mean, there's a difference, right, between this line and this line. This one's the slope is smaller. So, again, graph paper and ruler is essential. One way to check your solution is, well, let's see, do I have a little bit of time? I do want to check our solution. Like, how do you know it really is 1, 2? Well, all you have to do is substitute it back into your equation. So let's check our solution, right, which was 1, 2. And let's see if it satisfies the equation, meaning you generate two statements, true statements. Okay, so I get 2x minus 3y, right? That was the first equation. The second one was 2x plus y equals 4. Okay, all I'm doing is substituting 1 and 2, right, for x, or for x and y. So 2 times 1 minus 3 times 2, right, does that really give me 4? 2 times 1, let's see, 2 minus 6 is negative 4. Oh, that's why. My equation has a negative 4 in it. So, yep, negative 4 is equal to negative 4. Check. But it has to satisfy the other one. So again, true statement, TS. 2 times 1 plus 2, does that really give me 4? Well, yeah, 2 plus 2 is 4. So check. So because you generated two statements, 1 comma 2 is definitely the solution. That is the point of intersection. So again, it's a nice way to verify your solutions if you're not sure, if you have error.